Hey, welcome back to Famima Physics. In these videos, I am going to talk about units. Not units in battle, but units we use for measurement. So, I'm going to have two videos. This first video, I am only going to be talking about fundamental units and derived units. The next video, I will talk about unit conversions and showing us how to do that in a quick and dirty way as well. So before we start off, my question for you is, why do we need units at the end of our numbers? And if you're thinking about, yes, communicating, you have to be communicating what these numbers mean, you're absolutely correct. Because why? If you're going to tell me, hey, Miss Lee, I'm going to give you 5. Okay, well, first thing I'm going to think, oh, you're going to give me high five? But what do you mean? 5 apples? 5 houses? $5 million? Actually, I prefer the 5 houses because they're actually worth a lot now. Real estate? Yeah. So if you don't tell me what these 5 mean, they can mean anything. And causing a lot of confusion and misunderstandings. Same thing in the scientific world. Physicists, scientists all over the world need to agree upon one means of communicating measurement to one another, which is why they need units. Why we all need units as well, as young budding scientists like yourself. So what kind of units do we use? We use something called the SI units. What do they stand for? Stands for the International System of Units that are used globally. And you might be wondering, okay, if it's international system, why is it SI units? It's a French thing. Système international. Yes, international, okay, etc. My French is not that great. Anyways, so they're globally agreed upon units so that, say, as scientists here in Canada, if we want to talk about, if we want to communicate our measurements to somebody in, say, Sweden or Switzerland, we have agreed upon units that we can talk about. All except the United States. They're still working on the imperial system. But rest assured, the scientists in the States, the medical system, medical staff, and people that do scientific work, they all use SI units. Funny story is, I think I read an article somewhere where Pokemon Go became, I don't know if you're still playing Pokemon Go, but there was an article saying how the people in the States have to learn the metric system because Pokemon Go is in meters, kilometers, instead of what they're used to in miles and inches, etc., feet. Okay, so got another story for you in the next video about that. Anyways, let's talk about what the SI units are. You see a table here? That's it. Okay, you might be thinking, well, what about force? Newtons. What about the units we use for energy? Power. Wattage. Or volts that you see on your battery. They all can be derived from these basic units that you see here. We'll talk about that in a minute. These are the basic units that we work with as scientists. And that's why we call these fundamental units. They're like the building blocks of all your other units. The ones that we will talk about in this course, Physics 11, IB Physics 11, we will be covering meters, kilograms, second, not so much amperes. That's going to be in grade 12 IB, but we might get to it at time depending. What else do we have? Ampere, a Kelvin. Kelvin for temperature. We talk about that in thermal energy. Amperes, well, that's in electricity, obviously. Mole, that's something that you will deal with in chemistry if you are taking chemistry. When we will also talk about moles in thermal energy as well. Candela, if we do get to astrophysics, that's something we can use there as well, the candela. Okay, so another quick story. couple years ago, and you can see when this video was created, when I mean by couple years ago. A couple years ago, there's a redefining of the unit for kilogram. So before, what they do is to standardize all the measurements, the scales they use in grocery stores, that they use in the science labs, that they use in the pharmacy offices. They all standardize that based on a single hunk of platinum iridium metal in France. We call it a big K as a standard. They seal it up and they've touched it only like about 3 times or so. I might be incorrect there. But basically it was based on this physical object. And just a couple of years ago, they changed the where we get our units of the kilogram, and that's from from that physical property, which could change over time depending if it loses mass or it's properly handled and it gains a few micrograms. And you might be thinking, micrograms, that's nothing. Well, there, micrograms means a lot in the world of, say, pharmacy and the world of physics, chemistry. We deal with objects on the scale of atoms, subatomic particles, and even smaller than that, quanta quarks. So every microgram, even smaller than that, is very, very important. So it's a big thing. It must be agreed upon internationally for it to be universally used, and etc. So what they use instead is what we call the Planck's constant. Planck's constant, long story short, has to do with the conversion between mass and energy. So that has to do with Einstein's rule of relativity and a little bit on the speed of light as well. So the idea is to base these universal measurements on things that don't change over time. So natural phenomena, things that occur naturally that never changes. And one of those things is the idea how mass converts from energy to mass, etc. And that conversion is universal. It does not change. Part of that also, you can sneak in the idea of the speed of light. There's that involved as well. Of course, I can't talk about the whole details there, but the idea is things that don't change. Speed of light never changes, and it will never, ever, ever change. So, not even in the world of relativity. So, speed of light as a constant in your life is helping us determine the agreed upon units that we use. So it's really interesting, and how everyone has to all work together to come up with a way to properly communicate with one another in science. Sorry, I rambled there. Now let's talk more about what happens if we want to, say, find the units of newtons, energy, a force, momentum, which we will learn later on this year as well. How do we figure out those units? Of course, they have their own defined units, but then if we have to base them off these fundamental units, we have to start mix and matching and putting them together. These units, we call them derived units. For example, let's take speed. Okay, speed is a function of distance over time. If you don't know what function means, it means speed. You can substitute that word for, it depends on distance, it depends on time, and we use an equation for that definition. So what that is I have speed. I'm just going to use v here for simplicity. And then distance, we have distance on top over time, like this. So then my units for speed in that case would be, since I have distance on top, what measures distance? If you're thinking meters, good for you. So that would give us m for meters on the top, divided by time. What do you think measures time? You thinking seconds? Good for you. Absolutely. So that's the units we use for speed. Therefore, it's a derived unit. It combines fundamental units together. Let's use another one. Oh, goodness. I don't think you're going to know this one. But force is a function of mass times acceleration. Ooh, okay. Not expecting you to know this right now, but we just talked about it. Newton's force. It depends on mass, and it multiplies acceleration. So I'm just going to tell you what acceleration is. The units for acceleration is meters divided by seconds squared. You don't need to know what that means right now, okay? So let's just say we have to write the derived units for the force. What is that going to look like? What's the unit for mass? What do you think measures mass? You thinking kilograms? You are correct. Kilograms times acceleration, which then is this one I just told you, meters per second squared. These are the derived units for the force. And if you already know that, the other unit for force we use will be newtons, okay? So notice these are equivalent units. We have the derived unit for newtons, okay? The other thing that you will notice when maybe combined with units might be these other little tiny symbols which tells you how big and small the units are. So instead of writing 10 to the power blah blah blah, just like you would do for scientific notation, you might see these little tag-alongs to show you that instead. So for example, the milli, the centi you might have seen before, or the kilo. So for example, the kilogram, you know that one, and we just use kg instead of the grams. And in fact, I believe that's in your that's in the fundamental units anyways. The milli, so for example, millimeter, you might have seen that one. Centimeter, you might have seen that one. Okay, so then there's those ones. Kilometer, yes, kilometer. The kilo, again, the K, okay? So there it is. This table, you will get a copy of this one in your IB data booklet, so you do not need to worry about memorizing all of these. You just need to know what they're associated with. So for example, the millimeter would be, if you have the millimeter, so you have 3 millimeters, that's just 3 times 10 to the power of -3 meters, if you want to convert it back to meters. Oftentimes when you use Oftentimes when you have equations and the such, and you have to calculate a distance and whatnot, you want to be writing your answer in these base units, these fundamental units you see there, okay? All right, so that's the idea of fundamental and derived units. What do I need you to know? I need you to know the difference between a fundamental and a derived unit. I need you to know what the fundamental units are. In fact, in the IB exam, they might even test you for what they are. I need you to know where to find this table and how to use a table. Later on, we will practice. You will see more derived units and how to get them as we go on with the rest of this course. So hopefully this wasn't too bad. But the next video, please check that one out. I need you to know how to convert units. Very important. Anyways, thank you for watching this video. See you next time. Fatman Physics signing out.